Hey everybody, I'm going to go over some basic logic for us for when we're thinking about programming PLCs and other systems that we have in the lab. So for instance, I have two types of logic here. We have relay logic and ladder logic. Let's go over this relay logic and then we can see how closely it looks like the PLC ladder logic. So, from here, zoom out a little bit. Alright, so if you don't know, this is what one of our relays look like. It's an ice cube relay, and this is the kind of logic we can do it. So this would be if I gave you a wiring diagram, this is what the schematic would look like. So you have your coil, which is this part here of the resistor. I'm sorry, not resistor, relay. And you have your contacts here. This would be a button. That's a button. So here's our green button for latch. Here's our unlatch button, and that's going to power the coil. And then we have two contacts here. We got normally open and normally closed contact. That's all powered from the coil being closed or opened. So for instance, if I hit this green button, it's causing this to be powered, which closes this, which is our latch, which turns off our light. And then if I unlatch it, that unpowers the coil, and this closes, and you got light. Alright, so if we look at this, this is set up, and we just go over here to our ladder logic of a PLC. This is a PLC, and basically it kind of looks the same, right? So our ladder logic that we have here was based off of wiring schematics. So when people did all the wiring originally, they did everything in relay logic, and then eventually they came up with computers and stuff, and then we went over here to make it easier for people. They decided just to use the same symbols. Of course, they're all going to look a little different. Each company is going to have a different spin on a symbol that they make and whatnot, but we can kind of figure out what's going on here, right? So we have a memory bit here, which is kind of like our coil, which is an output, which is called control. So I have a button here that's hooked up, and then I have a normally closed button here, and then I have control. Control powers this, which was going to give us our latch, and that should turn off our light. So let me click this here. So light's on, see? And now it's off. And then if I want to unlatch it, when I hit the red button, this should open. Closing this again. So now, let's talk about what that looks like. So right here are the pieces of logic that we used in both of those examples. So we have our AND gate, we have an OR gate, and we have a NOT gate. So for instance, our AND gate, if we want to look through here what an AND gate is two of these in a row. So it says this and that, right? So you have two things, two inputs that need to be together to make an AND gate. This one, that input, and this input turns on the AND gate. We kind of have that in our ladder logic in a couple of different ways, right? So originally, I have this normally closed contact met for this, for instance, right? And then I need to meet this one on this latch to close it. So that's an AND gate. Okay. Now let's talk about an OR gate. What is an OR gate? An OR gate is this or that to power this. Okay, that's the best way for me to kind of like tell you about it. So I can either hit this input, which turns on the OR gate, or that input. I could push both of them if I wanted to. It works either way. And then we see that when we look at our latch. This input or this input will turn on control. Okay? So what does that look like? So that looks like this. So because the control is on, it's powering itself here. This input is an OR gate. Alright, now let's talk about the NOT gate. So here's our NOT gate. NOT is just inverted. So basically, when a signal comes through here, it's going to be inverted out the back way. So when I press it, it's off, it's on. And we can see a NOT gate down here at the bottom. When there's power to this, it's not on. When there's no power, it's on. And then you can use these 3 basic logic parts here to make really complex programs. So I don't want to don't underestimate these basic setups here, because they can be very useful when you're writing logic for your PLCs. And yeah, have fun.